This is Learning Module 9, Python, where we're dealing with how to use classes in Python. Basically talking about how to implement, this is the beginning discussions about how to implement the object-oriented programming concepts, principles in Python. So it's a different way of thinking, so let's get into it and talk about some of the uniqueness and these concepts about OOP, object-oriented programming. So we want to talk about what OOP is, those concepts, but basically how to use these classes and objects in order to solve problems. That's probably the biggest difference with this learning module that I want to try to accomplish, is that we can certainly do a video on how to syntactically use Python to develop a class, and then how to instantiate an object off of that class. I mean, actually go to YouTube and there's tons of videos on actually how to do that. Great videos out there to actually do that. What I want to try to do in this video, though, is to get you to start thinking about, it's one thing to know how to syntactically use the language, but it's another in how to actually solve problems using the object-oriented principles. And so it's a different way of thinking. It's looking at the world as if everything is an object, and well, everything is an object in the object-oriented principles. And so I want to introduce this concept, this way of thinking, get you down that path, and then we can talk about what does it look like to implement in Python. So now there are actually four major concepts in object-oriented programming. I only want to bring up two in this learning module. I want to bring up inheritance and encapsulation. We'll leave the others for another learning module like polymorphism and whatnot. Okay. So let's go ahead and dive into this. So what are we talking about? We're talking about classes and objects. These are two different things, okay? You can think of a class as kind of like a blueprint for a house, okay? A class is simply a blueprint or a template, and what it describes is it tells the computer how will actual physical objects be created in memory that represent the class. Okay, so the computer will use the class and it will follow it as a recipe, as a guide, as a template to actually generate objects. Okay, so that's a class. A class is simply a blueprint or a template. An object, the terminology we want to get used to, is an object is an instantiation of a class. You have to have a class defined, and when you have the class defined, then you can start creating objects of that class. Okay, so if I have a tree class, then I can start instantiating different types of trees off of that class. On the slide in front of you, if I have a bicycle class, it's a template. It'll describe how many tires does this bicycle have, how many seats does it have, what's the tire size, things like that. When we define it, we can then instantiate a real-world object off of that class. Okay. Another way to think about it, and you can pause the video and actually do this if you want, but I borrowed this, or I stole the idea off of this URL here. But if you think about it, these four pictures, 1, 2, 3, 4, is a recipe or a guideline or a template for how to build a paper airplane. You can think of this template as a paper airplane class. Okay. Now, it's not until you actually take a sheet of paper and do all of these individual folds, these four folds, will you then have a real object, an actual paper plane that you can fly down the hallway. Okay, so a different way to think about classes and objects to make sure you understand the differences between the two. Okay, now here's our basic premise. Once we have a problem that we're trying to solve, once we understand what that problem is, then what we need to do in order to think of solutions to that problem is we need to think of what objects are needed for the solution, and more importantly, how do those objects interact with themselves in order to solve the problem. In object-oriented program, when objects interact with each other, we call that object speak. Okay, and it's via objects talk to each other via methods, by the way, or functions in Python. In general terms, we call functions, we call them methods. So I'll probably be using that term interchangeably. So you're getting an insight into some unified modeling language, which is just a modeling language, a way to diagram. It's a diagramming technique to represent your classes that you have for your solution. Okay, so this is a very crude class diagram that you're looking at. Each one of these rectangles represents a class. Okay, don't worry about these extensions and whatnot. Just look at this first one. What we're doing is we're thinking of the problem. We're thinking about the solution from the objects that are needed to solve the problem. This is a bank account. Okay, and you typically have the name of the class as the first item, and then the attributes or the characteristics of the class are right below it. And then right below that are the behaviors or the methods or the functions of the class. So for example, for every bank account class that we have, the way you can describe the bank account is going to have an account name, and there's going to be a balance associated with it. And then the methods or the functions that a bank account has is that it can deposit money and you can withdraw money. Okay, so right now what we're suggesting, whatever the problem might be, we're kind of making this up, trying to introduce some of the stuff. Whatever the problem might be, we're thinking about, wow, to solve this problem, I'm going to need a bank account object to solve the problem. And that bank account object is going to have these characteristics, these attributes, and it's going to have these functions. Okay. All right, so a little bit more stating it, what I just said, but in unified modeling language, here is the icon that we use. The first entry in this icon is the class name. It's like identifying a variable. You come up with it. In Python, you typically, in other languages as well, you typically have the first, if it's a two words, if you're using two words for the name of the class, you typically capitalize both of them if it's a name of a class. And then this next section is the attributes or the characteristics of that class. And then below the attributes, you have what are the methods, the functions, what are the operations, what are the things that the class does. How will the objects of this class behave is really what you're answering. Okay. And so here's another example of that bicycle class. The attributes, you have the color of the bicycle, how many tires might it have, what's the diameters of the tire, okay? And then the methods, or how does a bicycle behave? The methods, the functions that it does, well, it turns right, it turns left, you can pedal it, you can set the color, meaning you could paint it, okay? That's what you can do with a bicycle, those functions, those methods, all right? All right, so let this sink in. Start thinking about all of these things we're talking about. We're looking at the world as if everything is objects. We're looking at the world and how objects interact with each other. And so we need to start thinking about solving problems in that mindset. So think about this. Here's a little exercise to get your brain working on this concept, and that is we have a problem. We want to develop a game. The game is very simple. The computer generates a random number, and then a player will sit there and try to guess what the number is, and they have to guess it within 10 tries, 10 attempts. Basically, the computer responds with, if the user picks a number, the computer responds with, are they too high, are they too low, or are they correct? So, we think about that problem. You can think procedurally. You can think, well, what do I need to do? I got to be able to ask the user for a number. Okay, well, then I got to pick, did the user guess the right number? You're thinking about it in procedures, in steps. That's procedural thinking, okay? The object-oriented way of thinking of solutions for a problem like this is think about what objects are needed to solve this problem we just described. Think about what objects are needed and how they need to interact with each other. Okay. A very easy first step that you can take for solving any problem like this is basically parse that problem statement. You're looking for nouns and verbs. The nouns become objects, the verbs become functions. Okay, it's not straightforward, but it is an easy first step. So you can look at it and you can see that all of the objects I've color coded red and I've underlined, and all of the functions I've identified in green. Okay. Now, you have to do some analysis yourself. You're not going to have classes developed for every red item here. Okay. But it's your first step to start thinking about what kind of classes, what kind of objects am I going to need? Am I going to need a game? Am I going to need a computer? No, that's pretty much one and the same probably. Am I going to need a number class? Not necessarily. The number can be an attribute of the game class, maybe. Okay. So that's what I'm saying is this parsing and identifying the nouns and the verbs is your first step. You then need to kind of coalesce, or how do I integrate all of these together to result in the final set of objects that I might need. Once I think I have an idea of what classes are needed / what objects are needed, then I need to start thinking about how they interact to actually solve the problem. So if you can think of this as a lifeline from the top going down to the bottom, I have a game object and I have a player object. I'm just proposing this right now during my analysis. And so for the game object, this is the lifeline. The game object generates a random number. Okay, so it's something that the game object does. The game object then might ask a player for a guess. What is their guess? So the player object will need to actually make a guess. The game object increments the number of attempts that are made. The game object determines whether they are too high, too low, or correct. The game object actually notifies the player object of the results. The game object also determines, does the player keep guessing? And if they are to keep guessing, then they basically loop back up. But if not, they end there. So what I'm trying to do here is I'm just trying to think of the world again. I'm trying to emphasize this. I'm trying to think of the world in the concept of objects. And more importantly, how do objects interact in order to solve problems, okay? And so I knew what the problem was, the guessing game. I started thinking about, parse the problem statement to try to understand the nouns and the verbs and what are the possible objects that might be needed. I put together this little flow diagram to try to see how does objects interacting, how might it solve the problem. And so that gives me a lot of insight into what classes that I might need to actually implement a solution to the problem. So then, based on what I think I understand, I'm going to propose that I have a game class and I have a player class. And so my game class has these attributes. These are the characteristics that describe the game. It has a correct number. This is the data type of the attribute, by the way. This is the syntax of UML. I'm not going to be overly emphasizing that you got to stick to the UML syntax. It's not something we've really utilized, but it's good to start introducing because UML is something that would be good for you to learn. But anyways, the attributes of the game class is got a correct number. It keeps track of the number of attempts, and it keeps track of how many guesses does any player get. Okay, so that describes the game. Now, what are the behaviors, or what are the functions? What are the methods that a game can do? How does it behave? Well, it generates a number. The game generates a number. The game determines, is the guess correct? It determines if its guess is too low. It determines if it's too high. And the game can respond to players. Now, my player object, here's my player class. The things that describe a player, the only thing I've identified to actually solve the problem is it has a number that it guesses, okay? You might say, well, does a player have a name? Well, it could, but in order to actually solve the problem, it didn't say it needed those little bells and whistles added to it. But I'm not saying that you can't have that. I'm just saying that for my analysis, I didn't come out with that was a needed attribute. To actually solve the problem, the player just has to have a number that it guesses, and it's got to be able to make the guess. It's got to be able to send whatever that guess is over to the game object. Okay. So let's let that sink in. Why don't you pause the video and just look at these questions right here? What is a class? What is an object? Make sure you're familiar with these concepts, and then think about what a class would look like for a bank account. Okay, what are those? And there's some insights. Don't cheat and go back a few slides. Just think about it right now. For your bank account, for your bank, think about objects. What does the bank account look like? What are the attributes of the bank account? What are the behaviors of the bank account? What does it do? Okay. And then whenever you are thinking about taking an object-oriented approach to coming up with solutions, what are the two major things that we think about in taking an object-oriented programming approach? So why don't you pause the video, think about it, and we'll get back to it right after. Okay, now you've had some time to think about it. A class is simply a template, a blueprint for how objects will be created by the computer. And then an object is simply an instantiation of a class. It's actually the item in memory that does get created off of the class. For developing a class for the bank account, you can go back to that slide, the previous slide. I forget which number it was, and maybe look at it from this perspective. So test yourself against slide 5. And then the last one is develop an object. What two things do we consider? The two big things that drive us is what objects that are required to solve the problem, and most importantly, how do those objects interact? So those are the two things that we consider heavily when we're taking a object-oriented programming approach. Okay. All right, so now let's move in. How do these concepts, how are they translated to Python? Okay, well, pretty simply, actually. To create a class in Python, you got to use the Python keyword class. Okay, you come up with the class again. So let's pull up our development. I'm using the idle development environment. It's very simple. Everybody pretty much has that. If you want to use PyCharm, that's something I actually use. PyCharm is very strong. Or you might use a Juniper notebook for that case. Anyway, so whatever development environment you want to use. But so example class for this video. Okay, so remember we use the keyword class. Okay, very simple. And then we come up with the name of the class. So I could say, let's just call this a person. And so just like with any Python structure that we've used in the past, in order to create a block of code, we end it with a colon. So class person, because this is where we might identify what attributes that we have, and then we might also identify what methods or functions, same word, that this class has. Okay, so this is where, the Python programmers are probably going to frown on me a lot because I come from a C++, Java world and learning Python, where most of the time you have your class separated up like this, where you define what your attributes are, like let's just say name. Okay, and I'm going to initialize it to be blank. Okay. And so this, you don't see this much in the Python. So what I'm saying is, right here is I'm trying to identify what the attributes are for my person class. So a person might have a height. Okay. Just say they're not tall yet at all when we get started. And what else? They have an age. And let's just say they're not born yet. Okay. So maybe this is the attributes, the characteristics that describe a person. Okay. The Python world, the Python applications I've been involved in and I've seen folks build, don't typically identify your attributes like this. You define your attributes in the constructor, and we'll get to the constructor here in a little bit. But so let's not jump into that and make it overly complicated right now. Let's just start off though with, let's just say our person class has a name. Okay, and so just a name is all they have. Actually, well, okay, that's good. We'll just leave it at that. And let's just say this person could also tell you what its name. So let's just create a function that actually has behavior of the person can respond with what its name is. Okay. Now, what I'm doing is I'm probably getting ahead of myself a little bit in the sense of um, getting a little bit more involved with the class than we need to at this point. So I'm jumping ahead in a lot of the slides once I go back to the slides. But I think it's important from this sense of let's just talk about what all we have to get a basic functional class going. Okay, so first of all, I have an attribute. The class has a characteristic. So this person class has a characteristic and it has a name. Okay, right now I have it set to nothing. You could have set it to, let's say every person object has the name Marcus. I could have set it to nothing, whatever. And then the only other method that it has, the only other function it has is that it can get its name, meaning if you ask for it, it can tell you what its name is. Okay. So in return, we should have a method or a function that will actually set the name. Okay. In Python, you can't really protect the attributes. But it's good programming if we do, meaning I'm creating two functions, two methods for this class right here. The attribute is name, and I'm creating two methods or two functions that allow you to not only get what the person's name is, it just returns the name. We'll talk about this self qualifier here in a minute. But anyways, the first function is it can get the attribute, the value of the attribute name, the variable name, and we're going to have a method that will actually set the value of the variable. And this method, this function, takes two arguments, self, we'll talk about in a second, and name. Okay, so with that, I can say self.name equals name. All right. So that is my class. My class has been defined, and I haven't saved this. Yeah, I have saved it. Okay, I called it class example 2. So my class has been defined. I can save it, and I can actually run this. As you can see, nothing happens. So it's interesting. Make sure you're familiar with this. When we have run in previous learning modules, when we've ran our Python script, then basically it starts at the very beginning and it goes boom, boom, this line, this line, this line, and it just starts executing code sequentially. Or if it hits a control flow construct, like an if condition or a loop, then it might take different branches, but nonetheless, it starts at the top and it just goes boom, 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 and executes all the statements. Well, as of right now, nothing has called or nothing has said for any of this class or these methods to actually execute. So we've ran this script file, but nothing has said for any of it to actually run. Okay, we haven't called for it to run. And so that's why over here in the interpreter, you're not seeing any output. Okay, so what we have to do is remember the definition of the class. The class is the template for how objects get created. So this is the template right here, how an object will get created. An object that gets created is going to have an attribute, and that attribute is a variable that's called name, and it's going to be set to Marcus. And this class, the object will have two methods or two functions. It'll have a getName function and a setName function. So that's the class, that's the template. Now, to actually instantiate an object of type person of this class, okay, then I can say my person equals person. That's all. This line of code right here, I created a variable, which is going to be a handle, an object to, or it's going to be a handle to an object that gets created. And I'm calling the person, this class, and I'm saying, hey, I want to have a object that is of type person. Okay. So now I could say, so now I have this object. So I could say print my person. Let's call its method getName. Okay, so I have this object right now. Here's the object. I'm going to print the object, and I'm using the dot notation to actually reference its method. This object is an instantiation of this person class. This person class has a method called getName. It actually returns a variable that's of type string, and so I'm going to print whatever that returns. So I'm going to save it, and then I'm going to run it. So you can see that it printed out the value of the attribute of that class. Okay, now what's important here, I'm going to get rid of some of this white space here, and I'll get rid of that comment. Okay, now what's important here is I created this object right here, my person, and it's of type, it's of that person class. Let's call it my person one. Okay, my person one. What's important here is I can create any number of objects that are of the same type, that are instantiations of this class. And so it's like a factory. All objects that get created of this class are going to be the same. So I can say my person 2 equals person. Okay. So let's print what my person 2's object. Let's print what its name is. So let's get its name and let's print it. What do you think it's going to be? Well, it's going to be Marcus, it should be, because all objects that are created of this class, that are created of this type class, have a attribute, a variable name, name, and of course it's set to Marcus. Okay. But now what's important, what I'm trying to get across to you here now is, what's important is I have two completely different objects. I'm sorry, two completely unique objects. They are built off of the same template. They're built off of the same class, but they are different pieces in memory. They have their own attributes and they have their own methods. So for example, if I wanted to say my person one dot set name, and set name, I pass it two arguments, self and name. However, you don't have to pass self. We're going to talk about that self qualifier in a second. So let's just pass it one argument, name. We know it's a string, so let's just call it James. And then my person 2 dot set name. Let's call it okay. And let's see what the effects are of that. I'll save it and run it. But what I want you to see is that initially when we printed out what the variables were, the name, the values of the variable name, the attribute name, you can see they are both Marcus. Okay. Then what I do is I change them using the set name method. And each object is different. So my person 1 set its name to James, and it has its own variable. And then my person 2 set its name. It has its own variable called name. And we're going to get its name and print it, and you can see the two variables are different. Okay, so it's important to see that, to understand that there's a distinction. When I create an object of this class, then a new section of memory gets created. Okay, if I create another object of this class, a completely different section of memory gets created for that object. And it has its own variables and it has its own methods. Now, we can force it to not have its own. Okay, we'll talk about it when we have class variables. However, for just getting started, let's not make it overly complex. Right now, if you create an object of this class, it has its own variables and it has its own methods. And we'll get into it again here a handful of slides later, but let's just talk about this self. Every time you create a class, for every method that you create of this class, the first argument that you have, so this right here, get name function, actually doesn't take any arguments. If you were to write this function outside of a class, okay, then you wouldn't be using the self argument. Okay, it would just be empty. All right. When we call the get name, you can see you don't pass it any arguments. What this self qualifier does is it allows the class to know. And for those that are in other programming languages, it's like using the this pointer. It has a reference to the object that is actually being called so that it knows, hey, I'm going to return self.name, meaning whatever object got called, I'm going to be using it to actually dereference which variable that actually needs to be returned. So we'll talk about this again, but for right now, know that when you create a method or a function inside of a class, make sure the first argument that you identify is self. Okay, we'll talk about using it as well in a second. Now, theoretically, you actually don't have to call it self. You can actually call it something else. But to stick with common practices and whatnot, I wouldn't try to get too fancy there. Okay. So we can create a class by using the class keyword. Here's another example. I'm giving you two examples. One that I'm doing in real time right here, and then one that's done here in the slides that I created. Okay. So I create a class here called guessing game. It has an attribute called max guesses. Then I can create an object that is off of this class by saying my game equals guessing game, and then I can actually reference this attribute directly. Okay, that's not good object-oriented programming. You want to enforce data encapsulation where I actually hide my data, my attributes, but for demonstration purposes, it's okay. What we would rather do is we would rather have methods or functions created that a user of your class has to go through the methods to actually get to the attributes. Okay. So here's a little bit more involved we're stepping it up a little bit, getting a little bit more involved, where I'm importing the random module so I can generate random numbers. My class is guessing game. So I'm starting to implement that problem that we had earlier in the discussion slides. So it's a guessing game. But I'm just showing you that here's the attributes for guessing game, and then I create my object off of it, and I can actually print and reference these attributes. Now here's a little bit more involved, but I'm wanting to show you that I can have two objects instantiated off of this same class, and they actually have their own separate pieces in memory. Okay. Now, what I'd said earlier, I guess I shouldn't. What I'd said earlier, I had said, well, I'm going to initialize this variable to Marcus. And I said, well, most of the times in Python, you don't see the attributes called out first. Okay. Well, typically what you see, and the reason why is I didn't jump right into this, but what we need to talk about next is this concept of a constructor. Okay. And so every time you create an object that is off of a class, remember the class is just a template, and we create objects that are of that type class. Every time we create an object, the very first thing that gets done is that a function, a very specific function in the class gets called first. So if I have, here's my picture, if I have a class, the computer is going to take that class and it's going to create an object of it. But it's at that point, right there, before it starts creating the object, that there is a special method that gets called, a special function that gets called first, no matter what. And we call that function the constructor. Okay. In Python, the constructor looks like this. It's double underscore init, double underscore. Okay. So in practice, so let's do this. So I'm going to create the constructor for my person class. So I said it is, so it's like defining any function, and then it's double underscore, then init, init, and then double underscore, and then parentheticals, the parentheses. Okay. Now, traditionally, again, we said, so that's what the function is. Let's just stop there for a second. That's what the function is. So you can do just like this. So in the constructor, we could say constructor, the purpose of the constructor is to initialize anything needed for the objects instantiated from this class. Okay. Now, what did I say about if you create a function inside of a class? What's the first argument that you have to have? You have to have self. So I'm going to have self. Okay. Now, typically in the constructor, what you see in the Python programming is typically in the constructor where you have the attributes of the class that get initially identified. Okay. So if you see up here where I have name equals Marcus, typically this is where you have name being initialized. Okay. Or this is for Python. You typically in the other programming languages, you got to identify all your data up front, and then the constructor is used to initialize the data and whatnot. Okay, so I'm going to take it out of here just to stick with the common Python approaches, and I'm going to initialize my attributes here. Okay, now when we initialize our objects from this class, typically what folks will do is, like down here, this is me initializing or instantiating an object off of this class. Typically what folks will do is they will initialize, they'll say, hey, I want to create an object of type person, and hey, here's the initial set of values for this person. So they might say, here's its name, and here's their age. Okay. So with that, my constructor should be able to receive those same things, those same arguments. Okay. Now, I kind of worked backwards. I said, if I'm an object that's instantiating something of this class, then they're going to send me two arguments. I kind of worked backwards. What you have to do is you have to look at your design, and you have to say, for my person class, what attributes does a person have? And we might have said what has the name, age. Well, let's just say that's all it has. Okay. All right. Well, then these are the attributes or the variables that need to be initialized when someone creates an object of this class. Okay. So we define our function. Here's our constructor. Double underscore init. Use the parentheses just like you do with any function. The first argument is always self. And then what attributes are you wanting to initialize? Do you want the object that gets created to have what variables initialized first? Those are the arguments that come next. Now, this is where the qualifier self comes in, because this is where you're going to say, well, the object that's being called, which is self, I want to initialize its attributes or its variables. I want to initialize them. So it's got to be able to differentiate between that and the variable that belongs to the class or the object. And it's got to be able to differentiate between that and the argument being passed to the function. So for example, here I create an object, my person1, that's of type person, and I pass it two parameters, two arguments. The first argument is a string with the value Marcus. So that's going to be passed to this variable here. Well, we need to be able to differentiate this argument with the class variable, with the class attribute. And so we use the self qualifier to actually dereference which variable are you talking about. Well, I'm talking about the variable that belongs to the class. Okay, so it's going to be self.name equals name and self.age equals age. Now, I do not have to use name and I could have said X and Y. Okay, I could have done this. Okay, but you'll typically see in Python the programmers will use the same name. Okay, so I'm just trying to, even though we jump around programming languages a lot, it's, to keep it straight in our own heads. In my head, I try to be consistent with what I see other Python programmers do. Okay, so that's the init function, the constructor. So I use this constructor to basically initialize any of the variables that I have. So if I want to, so this initializes it, I can say, okay, Marcus, and then let's initialize my person2 to be James, and they are 50. Okay, so we don't have to set the name anymore because I already set it. Although if you want, if the person actually changes the name, then you certainly have a method or a function to be able to do that. So now I can save that, and now I can run it. Okay. And you can see I create two objects. I initialize those objects by passing in two arguments. I got my person one object, my person two object, and then I print their names. Okay. Now, theoretically, what I should have to make this a fully qualified class is I should have methods here to get age, not ret run, return, okay, and I should be able to set their name or increment their age, maybe. Okay. Whoops. Let's say increment age, and I'll say self dot age. And let's just stick with set age. Let's just not have to make it more complicated than we do. Self dot age equals age. Okay. So that'll allow you to modify the attributes without actually calling the attribute itself directly. Like for example, we could easily say my person one dot age equals 13. You can manipulate the attributes or the variables of the class of the object directly. Python doesn't restrict you doing that at all. Okay, I'm just in sticking with data encapsulation and proper object-oriented programming principles. We should have to go through a method to actually manipulate the values of the attributes. Okay, we shouldn't do this directly. Okay. All right, so let's go back to slides. Where were we? That's the init, the constructor. Here's the constructor being defined for the guessing game. I'll let you take a look at that. You can pause the video to be able to see this other example. All right, let's dive a little bit more into this init function, the constructor, to make sure you fully understand what it is. So the double underscores, then it's the word init, I-N-I-T, another double underscore, and then your parentheses because it is a function. So of course now it can take a set of arguments. All right, the first argument is always self, and then arg1 all the way to argn. Okay, however many arguments it takes, they're separated by commas. Okay, and the thing to remember, this init or any constructor, but in Python it's init, double underscore init, the constructor is called, that is the first method that gets called when objects are created of this class. Okay, so you can see that. And what I say is you can see it happening if inside I'm going to put this. I'm going to just put a print statement. It's not good programming, but I'm going to do it. Print, I am in the constructor. Okay. So you can see the effects of this. I'm going to run this, and you can see. So right down here, my person one, it's going to create an object. Okay. And so when the object gets called, the first method that gets called is the init. So of course this print statement is going to execute. And that's why you see I'm in the constructor. So then I create another object, my person two. Well, guess what? It's in the constructor. So of course this print statement is going to execute. And then it's going to print get name, get name. So you can see the effects. The constructor gets called. That's the first thing that gets called whenever you're creating an object of a class. Okay. A little bit more detail, just involving that guessing game a little bit further. You can pause the video and study that if you want. All right, now let's get into their methods, classes and their methods. So in our example, I keep saying methods. Remember, it could be functions, okay? So here is a function. That is a method of the class. Okay, you create them just like you do any other functions. The difference is the first argument to the function has to be self. If it takes no other arguments, then it's just self all by itself. How about that? Okay, so you create them just like you would any other function. And then whenever you actually call the function, when you make a method call, then that's where you use the dot notation. So the object, my person two, is calling its method get name. So in this line of code right here, my person2 object is calling the getName method that it has, because it has this getName method, because this object was created off of this template of a class. So it has a getName function, and I call it by saying myperson.getName. Okay. All right, so here's just, again, a little bit more detail about that guessing game. All right, now a little bit more. This is where I bring up the referring to self. So you can see here in this little example class, my class, here's the attributes, number equals 0, flag equals false. Again, this is back to my Java and C++ programming days. And then here's my constructor. The constructor is in double underscore init. You should be familiar with that. The first argument is self. Well, the first argument has to be self. If you actually leave it out, I'm almost positive by default it gets inserted for you, but it's just good practice to make sure you include it. The purpose of it is so that whenever the function gets called, when the object calls its method, then the method, when it actually executes and it gets the processor time, then that self argument is actually a hold, a handhold, to where it has a reference to itself. It has a reference to the object that made the call. So for example, in this simple example, my person object is calling getName. Well, when the getName function, when the instruction pointer of the processor is pointing to the function getName, well, now getName has a reference to what object in memory actually made the call. And so it'll know that the myperson2 object actually made the call to the getName method. So that's why you're keeping a reference to who actually made the call. So that's how we're using that self. So when we say something like return self.name, so you're going to say return name. Well, which name? I've got two objects in memory. So which one? Well, I'm using self to resolve which one. Okay. All right, now let's talk about what I've been doing here is I've created the class, okay, and it's part of my file. It's part of my overall script. I've created my class, but I've also have just regular Python instruction code here, okay. So let's try some. What I want to do, though, is I want to create a class in a separate Python file. So if I say new file, and I'm going to say, well, let's just keep it the way it is. That's class example. I'll just do that. So what I want to do is I want to take out my code, my script that's just using the class, and let's just put it over here. And I'll save this. Let's do this. So what I've done is I'm creating I have my file over here, and this file is just going to hold my class information. I'm not going to have any of the code that was executing. I cut that, well, I mean, I shouldn't say not executing. This code will execute, but all of the code that is using this class, I'm going to put in a different file, okay? Now, and it just keeps things a little cleaner is all. So now I got this person class all by itself. I have saved it. It's called class example2.py, and inside of it is a class called person. So for me to use this class, what I need to do is remember our import where we import our modules. Well, I have to say import, what's it called? Class example2. Okay, so I've imported that, but now here's the catch. For me to reference this person class, then what I have to do is I have to qualify it and say, I've imported the module, okay? Just like we do the random class. Whenever we say import random, and then we want a random number, we say random.randint, okay? Well, in this case, I have to say I've imported the class example2, so I need to make a reference to it to call the person class, okay? Let's do that for both of them. And let's save it. And let me just clean up. Let's just get rid of a ton of this so you can see some of this. Okay, so let's run the module, and you can see still doing the same thing. Let's get rid of this I am in the constructor. Get rid of that, and let's say, yeah, I gotta save that. Okay. All right, so now this is awkward, right? That I'm making this class example. It's not that awkward, actually. It's actually decent programming because I'm going to force the programmer to know what module and class they're actually using. It's actually good programming because most people just import everything. But however, an easier way to do it is I can say from class example 2, import person. Now the computer is going to know when you make a reference to person. I can get rid of this qualifier now. When you make the reference to the person class, it knows where it's actually going to get the class from. So I can do this, save it, and run it, and I should see the same output. Well, minus the I'm in the constructor. Okay. All right. So this is it's much cleaner to where I create my class in a completely different file. It has it has its attributes in this file, and it has all of its methods. And then I have a completely separate Python file, that actually uses this class. Okay. So that's the point of separating things like that. All right. So here's the guessing game. It's getting a little much bigger now. So, but here's the whole class, and it's in its own file, but you can pause it here, and you can carry this over if you want, or copy it in and use it if you want. Okay. All right. So one thing that you want to do, I want to kind of pause and create a challenge for you. I want to create a math game. And so create a math class, math game class. And this is the functionality that I want the class to have. I want one method to randomly create a mathematical operation consisting of two numbers. So you basically want a class that can randomly generate a method or randomly generate a mathematical expression like 3 plus 4, 2 minus 4. So you want the computer to automatically generate those mathematical expressions. You want a method to be able to print the equation to the screen. You want a method to be able to get the correct answer. And you want a method that can get the user's answer and will tell them if they are correct or not. Okay. So here's an assignment for you. The challenge is to create this class. Now, the last couple of concepts that I want to talk about, we want to talk about inheritance and data encapsulation. Data encapsulation, that pretty much ends us, wraps us up. Yep, encapsulation. So inheritance, let's just jump into that now. This is a pretty long video, but maybe I can get these knocked out in 7 minutes, and it's just an hour. I say just an hour, it's pretty long. So in object-oriented programming, and object-oriented design, or specifically object-oriented analysis and design, you pretty much have four major concepts that define your object-oriented concepts. Okay, we're only talking about them. We're only talking about here. Okay, we're only talking about inheritance and encapsulation. I'm not talking about abstraction, data abstraction, and polymorphism. I'm going to save that for another discussion probably. So inheritance, let's just talk about this. So one of the benefits, okay, so earlier when we were saying it's a whole new way of thinking about objects and how do objects interact to solve problems, those are the two main things that we're focused on, that we're thinking about when we're trying to implement object-oriented concepts to solve problems. One of the most powerful attributes of object-oriented analysis and design is this concept of inheritance. Okay, and it's very simple. Inheritance, just as you know the definition in normal life, you know, like who are your grandparents, who are your parents, who's your great grandparents, what have you inherited from them? Okay, I'm not saying money. I'm not saying land. I mean, it could be, but I mean just your traits, your characteristics. What have you inherited? Okay, now let's apply this to what we've already learned. So when we were talking about earlier, let me just scroll up here. When we were talking about this bicycle, for example, here's the bicycle class. It has these attributes. Okay, if I create, or if there's a way that I can create a child of this bicycle class to where the bicycle was the parent to this other class that I'm creating, then maybe through inheritance that the child class could inherit all of these attributes. So that I actually, when I create the class, the child class, I don't have to create any of those attributes. I don't have to create any of these methods. Okay. So for example, I might want to create a Huffy bicycle, and it's a child of the bicycle class. Well, the Huffy bicycle is going to have a color. It's going to have number of tires. It's going to have tire diameter. It's going to have all of these attributes. So to save me development time, how about I create just a very unique type of class that is of type bicycle class, but it's a child of the bicycle class, so that I can just inherit and reuse all of the things that were already built for the bicycle class. So the inheritance concept is trying to get us so that we become cleaner and we reuse the things that we've already built. Okay. Terminology. The parent class is the class being inherited from. We also call that the base class. The derived class, or the child class, is the class that inherits everything. Okay, the child class does inherit all attributes and methods from the parent. Very important rule that you got to remember. Okay, so the child class does inherit everything. So here's an example. Okay, these are two different files, by the way. All right, so very important. This line is trying to depict that these are two separate files. Here I have a person class. Here's its constructor. It takes a name. Oh, very similar to what we were just doing. I actually wasn't planning that. There's a person class, the constructor. It has two attributes, a name and an age. It has one method. It can change its name, and it has another method. It can get its name. Okay. So that's the person class. Now, down here, underneath of it is another file. But I'm going to create a class called student. Okay. Now, what I'm going to do is a student, think about this, and think about it from an object-oriented concepts perspective. A student, think in objects, all right? You got a person object that's there, all right? And a person has a name and it has an age. Well, is a student similar to a person, right? I mean, maybe somebody could argue that no, students aren't people. I'm kidding, by the way. But anyways, so what we could do is reuse this code that we've already written up here in the person class and say, hey, I want to create a class called student, and I just want to reuse everything that the person class already has. So I've got student class. There's only one simple difference, and it is instead of me doing bad choice. Instead of me doing class person, well, no, in addition to me doing class person, then in parentheses, you identify what parent class that you are inheriting from. So it's in parentheses that you identify the parent class. So let's just say I had a class called parent. That's what I would write. And by doing that, I would be saying that person, let me just do that. Let me just make up something. Well, no, I'll do it down here. I'll say class student is a person. Okay? So I've created a completely different class called student. However, I'm identifying in the parentheses that, hey, I want this student class and every object that gets instantiated off of student, I want them to have all of these things that the person class has. It has a constructor, it has 2 attributes, and it's got 4 methods. And so by me inheriting from the person class, the student class is going to get all of this. Now, the minute I do this, I say that every class has a constructor. I'm not lying. I might say this. The minute that I create a method that has the same name as the parent class, then what we say is that this method, this function, overrides this one. So I no longer inherit this function. Now with constructors, it's a little different. I can call super and have it be called. But let's just say I say def get name. Self, I'm going to return self.name plus Mr. Doodle. I don't know, I'm being silly. My point is this. Student class now has a method called getName. Now wait a second, its parent has a method called getName, and it returns just the name. Very true. Now that I have a method that is the same name as the parent, I have now overridden how this parent method behaves. No longer, if an object of type student calls its method getName, it will not use the method that belongs to the parent class. Now it will use just objects that are of type student will use this method. In addition to returning its own name, it will also return Mr. Doodle. Okay. So this is me inherit. So when you inherit things, that's great. But remember, if you create methods that have the same name as the parent, then what you are doing is overriding that behavior, or overriding that function. Sometimes you want to, sometimes you don't want to. Okay, just depends on the problem that you're solving. All right, so here's the inheritance where you have class person, then here's a class student that inherits from it, and then here's actually using the classes. So you can pause the video and actually type that in. All right, now the last concept I want to go over is basically encapsulation. This is a fundamental concept in object-oriented programming, and this is where we want to hide things. Okay, we don't want folks that use our class or the classes that we create, we don't want them manipulating the actual data that's inside the class. What we're trying to do is encapsulate the data and the methods that operate on that data into one bundle, into one class. Okay, so for example, this is a person class. I actually misspoke a little bit. Sorry about that, but I didn't misspeak that badly. Here's a person class. Everything, so we have attributes that define a person. Okay, so we have weight. Okay, that defines a person. Height. Okay, that defines a checking account balance. Wait a second, that doesn't make sense. Does a person have as an attribute, a characteristic, a way to describe the person? Do they have an attribute called check account balance? Does that describe a person? No. So that attribute actually doesn't belong to a person class. Okay. What we want is for encapsulation, we want to be able to have all of the attributes, which become variables in Python, that represent the class. They've got to logically belong to the class. I also have a method down here, make deposit. That makes, well, actually, it does kind of make sense. They could make a deposit, but it would make more sense if I create a banking object or a bank account object and put this method and these attributes as part of that class. Then I would be encapsulating the right attributes with the right class. Okay. So encapsulation is where we try to hide things. We want the data or the attributes that describe the object. We want that hidden from the outside users, the folks that use our classes. We want to hide it. We want to give them limited access to it. And all of the attributes that we have that define the class, we want them to logically belong to the class. We don't want anything extraneous type of attributes that do not describe or don't belong to that class. They shouldn't be there. If you're doing that, then you're not practicing data encapsulation. Okay. Where we've already talked about this concept, by the way, let me get back to our class here we created with class person, where I defined these methods to actually get the values of our attributes. That's what we're doing. We're practicing data encapsulation here, okay, so that they don't actually directly access these variables, these attributes, okay. In other languages or in the object-oriented world, we call these getter methods, where you get the attributes, and we call these setter methods. So to a fully qualified class, you make sure that every attribute that is open to be written to, then they have setters and getters, and that's what that means, okay. All right. Now, Python implements this concept where it implies it's private. So if you ever see variables inside the class, if I was to say something like this with double underscore, then that is implying that that is a private a variable, but it doesn't constrain it. The interpreter doesn't constrain it. You can still write to it. But we're not going to get into that right now with this learning module, but I wanted it there for completeness sake. Okay. All right, so here's the last challenge, and you'll see this in the coming weeks. The last challenge is basically implement a class hierarchy for geometric shapes. All right, this was a long learning module. I apologize for that. I kind of wanted to compare and contrast. I've been building very small learning modules, and so I wanted to build a big one to actually just see how does that work for our learning approach that we're doing. So, okay, so this wraps up learning module 9. It deals with classes and objects, although we'll talk about classes and objects again, but this was the introduction to classes and objects.